Hey Algebra 2. So far in class, we've only discussed and explored some ideas and concepts surrounding graphing functions of quadratics. We've talked about the relationship between a vertex and the axis of symmetry, also the intercepts and the axis of symmetry, and we have also seen that if we have an input and an output, one coordinate, we could actually find another input and output on the other side of the axis of symmetry. Now, in this video, I want to show you guys how to graph these types. The last one is a challenge, and it has to do with graphing and factoring. First, in the book, it doesn't show this method. I just thought it was an interesting challenge based on the factoring that we've done in class, and also the relationship between the intercept form and the standard form. So, for each graph, you're going to have to find and label the equation of the axis of symmetry, the coordinates of the vertex, and 4 points in addition to the vertex. They can be the intercepts if you're graphing in intercept form. So for the first graph, we're going to start out with finding the coordinates of the vertex. And that is because it is in vertex form, so you can easily determine that the vertex is -7, -2. And remember that the input of the vertex has to produce the output of -2, and the input of -7 will make this quantity 0, and so you will be left with -2. -7 produces -2. Let's go ahead and plot that. Now notice that I'm plotting just on blank paper. I don't have any increments. I don't need increments. So I'm just going to say if that's 1, okay, that's going to be -7. I don't know why I put a dot there. And let's say this is 2. Okay, so this is going to be the coordinate, -7, -2. Now, I know right off the bat that x equals -7 is going to be my axis of symmetry. Again, ignore that other point. I don't know why I drew that. Okay, so I'm just going to try to make the line as straight as possible here. Okay, so this marks the axis of symmetry, which is x equals -7. And now we need to find other points. Now, with the vertex form, we're going to have to find 4 other points. I'm just going to scoot this down here. Okay. And I'll make a note down here too that the axis of symmetry is x equals -7, so we can look at that. Now, if we have 1x, let's say that we find f of -5. Okay. So what I'm doing is I'm picking a point. It doesn't have to be -5. I just picked a point that was close to -7. -5 is 2 from the right here. Okay, so it's going to be close to the vertex. And I'm going to find the output if the input is -5. So that is 2 squared, 4 minus 2 is 2. And so the point -5 2. And then I'm going to label it. Okay, so that's that point. Now the other point that produces 2 has to be 2 away from 7 on the other side. So the point that's 2 away, basically, if we were looking at the arithmetic part, I mean, we can look at it here. We know that if -5 is 2 to the right of -7, then we need to find 2 to the left. So that's actually going to be -9. Using arithmetic, we can say that -7 plus 2 is equal to -5, and -7 minus 2 is equal to -9. okay? Now we need to find two other points. So substitute in another value for x. X is equal to -2. That gives you -2 plus 7 is 5 squared. 25 minus 2 is 23. And so we have the coordinate -2, 23. And seven is 5 units away from -2, so we want to find out what -5 units from -7 is, and that would be -12. Okay, so we're finding the point on 5 units to the right of -7 is -2, and 5 units to the left of -7 is -12, and so we have the coordinate -12, 23. Oh yes, and this was -9, 2. So now we have to go back to the graph and plot the points -2, 23. And I'm going to try to get as close to the scale as possible. So, yes, right. All right, so it's probably going to be about there, -223. And then the same distance on the other side, roughly -12, 23. Now for drawing, the parabola should be U-shaped. So you're going to do your best work trying to make a U that passes through these points. Now, I'm not expecting perfection here, but there should be an attempt at making this really curved, to make a U, and to make it curve up so that it advances out, so that the it appears that the graph is increasing in the input here and decreasing in the input there. We don't want any curves like this. Curves like that wouldn't make much sense, and that's what people tend to do. That's like they're trying to make an ellipse. It's not an ellipse, it's a U that actually, if we could continue it forever and ever and ever, we're going to always have increasing output, increasing input, and increase as the input increases, as the input decreases, the output will increase. Okay, so that's in vertex form. Now in intercept form, some of the process is the same, but not until the end. To start out, since we're given the intercepts, we're going to have to start out finding the axis of symmetry, not the vertex. We can't easily find the vertex from the intercept form. So the intercepts, just by looking at the equation, these are the values that produce 0. And so these are your two values that produce 0. There we have 7, 0, and -5, 0. So I've found and plotted the intercepts. Now finding the axis of symmetry is in the middle, or is the average of the intercepts, because these are two inputs that produce the same output, and so the axis of symmetry should be right in the middle there. We could draw it now probably just by eyeballing the graph, but we want to actually find the value. -5 plus 7 divided by 2. So -5 plus 7 is 2, divided by 2 is 1, and so the equation of the axis of symmetry is 1. Now we know the input of the vertex, because we know that the vertex is on the axis of symmetry. So let's go ahead and draw in that axis of symmetry, and also kind of plot the location of the vertex. Sorry, not the location of the vertex yet, because we don't have the output. Okay, so the axis of symmetry is going to have the equation x equals 1. And now for the vertex, we need to actually put in the value of x into the equation. So we're actually finding h of 1 is equal to 1 minus 7 times 1 plus 5. And so we get that that's negative 6 times 6, which is going to be negative 36. And so that's the point 1, negative 36. Because h of 1 equals negative 36. So in order to get a pretty realistic graph here, so my graph looks nice, I'm going to go ahead and keep the scale of negative 36. So I'm just going to, I'm still going to eyeball it because I'm going to say, okay, well, if this is about 5, then I'll go down by 5s. Okay, so we have 5, 10, 15, 20, 25, 30, 35. We're just going to say that 1, negative 36 is down here. Now, in order to find the rest of the parabola, we actually only need to find 2 other points. We don't have to find 4 other points, see, because we already have 2 points up here, and in order to get a good picture of the parabola, we only need to have 5 points all together. So I'm just going to push this up here so we can see the work. So I've already decided that I'm going to plug in a 6 for x. And so my value is going to be negative 1 times 11. And so that's going to give me negative 11. So 6 negative 11 is 1 point. Now remember that my axis of symmetry is 1. And so the distance between 6, that's going to be on the right, on the left, not 6. Sorry, I messed these up. It should be 1 and 6. If we add 5 units to 1, we get 6. So in order to get the coordinate on the other side, we need to subtract 5 units from 1, and we get that it's negative 4. And so we get that 6, negative 11, and negative 4, negative 11. Now again, this is totally a sketch, and I'm sure that some of you guys would do a much better job at being accurate. Now, one thing that we want to do here is we don't want to make it look like a V. So go ahead and try to make this a U. And then we're going to try to make our points go up through here. Yeah, it's not exactly excellent, but you get the idea. You get the idea. Okay, probably should have made it more curved. So even though we have not the best parabola ever in the world, but what I'm looking for is the intercepts, the axis of symmetry, the vertex, and then finding the points that have the same input. The drawing sometimes can be a little problematic, you know, it'll take some practice. I think I needed to put this a little bit more on this side, but you get the idea.